Alright, good. You made it to the last page, which is the second example. I know these can be pretty long, so there's only 2 of these, and I'm not going to give you much homework following this. But so here we have another second order differential equation, which is set equal to e to the t times arc tangent of t. So in order to solve this, again, we know that we're not going to be able to use undetermined coefficients because of our g of x. So therefore, what we're going to have to do is we're going to have to use our variation of parameters. And we want to solve this, so we need to find our y sub c and our y sub p. So let's find our y sub c first, because that will help us find our y sub 1 and our y sub 2. Again, we're going to have 2 solutions to the homogeneous part because we have a second order differential equation. So I'm going to set up my auxiliary equation, and I'm going to get m squared minus 2m plus 1 equals 0. And when I solve, I realize that m sub 1 is equal to m sub 2, which is, because when I factor this, I'm sorry, I jumped ahead. When I factor this, I'm going to get m minus 1 squared equals 0. So that means that both m sub 1 and m sub 2 equal 1. So my y sub c is really c sub 1 e to the x plus c sub 2 x e to the x. So now I found my y sub 1, which is just e to the x, and I found my y sub 2, which is just x e to the x. Now I'm going to write all my Wronskians right here, so I'm going to first do the original, which is just w, and that's going to be e to the x and x e to the x. When I take the derivative of e to the x, that's easy, it's just e to the x. But when I do the derivative here, what I realize is that it's a product rule where I take the derivative of the first, which is just 1, so it's e to the x, plus the derivative of e to the x, which is e to the x, so x e to the x. And so now I do the determinant, I multiply this, so e to the x times e to the x is going to be e to the 2x, plus x e to the 2x, minus, and when I multiply these, I'm going to get x e to the 2x. So the x e to the 2x's are going to cancel out, so my Wronskian is just e to the 2x. My Wronskian sub 1, I eliminate the first row with 0 and f of x, which f of x is going to be e. Oh, brother. So I'm just going to go ahead and change this to e to the x tangent, arc tangent of x. And then at the end, I'm just going to replace all my x's with t's. And so I get e to the x, arc tangent of x, and then x e to the x times e to the x plus x e to the x. And so when I do the Wronskian here, the first part's going to cancel out. So it's just minus x e to the 2x arc tangent of x. And then let's do Wronskian sub 2, and so now it's just going to be e to the x, 0, e to the x arc tan x, multiply here, and I'm going to get e to the 2x arc tangent of x. And so now, to find my u sub 1 prime, I'm going to go ahead and do w sub 1 over w, which is just negative x e to the 2x arc tangent of x all over e to the 2x. And so what I'm given is negative x arc tangent of x. And now I want u sub 1, so what I need to do is I need to integrate this. And so that's what I'm going to do. I'm going to integrate that. And so now, when I integrate this, what I realize is that in order to do this, I would probably like to use u substitution, where u is going to be equal to arc tangent of x, and my du is just 1 over 1 plus x squared dx. My v, and then my dv, so my dv is just x. So that means my v is going to be x squared over 2. Now I'm going to substitute that in. So I'm going to multiply my uv, and I'm going to get, and since there is a negative on the outside, it's going to be negative x squared over 2 arc tangent x and then minus the integral of x squared over 2 times my du, which is going to be 1 plus x squared dx. And what I'm going to do is I'm just going to keep this negative on the outside for now, not distribute that negative in. And so after I do this, I'm going to work on a few things. And so I'm going to have this equal to negative x squared over 2 arc tangent x. And then I'm going to go ahead and pull out a 1/2, so minus 1/2 the integral of x squared over 1 plus x squared dx. And what I'm going to do is I'm going to add 1, subtract 1. That way I can go ahead and make this whole thing just 1, and it be over, minus 1 plus negative 1 over 1 plus x squared. So then I'm going to have negative x squared over 2 arc tangent x minus 1/2 the integral of 1 minus 1 over 1 plus x squared dx. And so I'm going to have negative x squared over 2 arc tangent x minus 1/2 times x minus arc tangent x. And so cleaning this up, I'm going to get negative x squared over 2 arc tangent x. I'm distributing the negative. If I distribute that, so it's going to be plus 1/2 x minus 1/2 arc tangent x. And that's going to give me 1/2 x minus arc tangent x and times x squared over x squared minus 1 over 2. We'll just write that for right now, and then I'll clean that up a little bit more as I write the answer to the last part. So now let's find y sub 2 prime. And again, I'm going to use Wronskian sub 2 over the Wronskian, and that's going to be e to the 2x arc tan x over e to the 2x. So all of that is just arc tangent of x for my y sub 2 prime. So we integrate that, and if I integrate this, I'm going to use u substitution again, where in this case u is going to be my arctan of x, and my d and my dv is going to be just 1. That means my v would be x. And if I did that, then u sub 2 is going to equal x tangent, or inverse tangent. I'll say inverse tangent instead of arc tangent, just to write that. It's a little bit easier to write inverse tangent than arc tangent, I think. X minus 1/2 natural log of 1 plus x squared. And now, I need to write my y sub p. So my y sub p is going to be u sub 1, which I'm just going to go ahead and pull out a 1/2. So 1/2 times x minus, and that should be a plus 1, x squared plus 1 arc tangent x times my y sub 1, which is e to the x, plus my u sub 2, which is going to be x arc tangent x minus 1/2 natural log of 1 plus x squared, times my u sub 2, which is just x e to the 2x. So therefore my y sub c, my y is equal to c sub 1 e to the x plus c sub 2 x e to the x plus my particular. And I'm going to go ahead and just write, I'll just write it how it is. 1/2 x minus x squared plus 1. I'm going to go ahead and just say inverse tangent because they're the same. X times e to the x plus x inverse tangent of x minus 1/2 natural log 1 plus x squared times x e to the x. And there's your solution to that differential equation. Now, I'm not going to give you a whole lot of these to do, just because it's very easy to make a mistake, and it will take some time. Again, these are a little bit more difficult integrals that you're going to be working with, so I'm not going to give you too many. Hopefully you are staying healthy through this time, and if you ever need some help, just send me an email and I'll get back to you. All right, y'all have a great time. Bye.